warahmatullahi wabarakatuh dan selamat petang. First of all, I'd like to thank the main organizer for inviting our department to give a presentation in these symposiums. Let me introduce myself. I'm Abdul Rahman Jazuli from Jabatan Ukur dan Pemetaan Malaysia. And my topic today is SmartKADASTER, role of Geomatics in supporting smart city. Okay, let me start with the topic of smart city. What is actually a smart city? Actually, there is a lot of definition about a smart city, but what I like to share with all of you today is a definition by Karakliu and Nishkam in the years of 2009. It says that a city can be defined as smart when investment in human, social capital, traditional transports, and modern ICT communication infrastructure fuels sustainable economic development and a high quality of life with a wise management of natural resources through participatory actions and engagements. So when we talk about smart city, we also talk about a city. So for today, I'd like to share some information with all of you about a city. Okay, this is about the rise of the city. And this is the report. This is the reports from the source of United Nations. The reports on World Urbanization Prospect was published in 2018 about the world's population resides in the urban areas. It says from the report, it said that in the years of 2017 and 18, it is about 55% of the population that live in the urban areas. And the figures increased to the years in the 2050 with 68%. And the interesting part of this report is that from this 68%, it says that 90% is in Asia and Africa. They focus an example like in India, the population that live in the urban areas will be 416 million, China 255 million, and in Africa, Nigeria, it about 189 million. And from these reports, how about our country, Malaysia? For Malaysia, there is another report from UNICEF, Reports and Urban World. It says that in the years of 2017 to 2020, our population will be 25 million, with 78% of the population will live in the urban areas. While in the years of 2050, the figures increase to 35 million, and the population that live in the urban areas is about 88%. So it seems that it's like a big challenge on how to manage a city. And from the definition of the smart city earlier, seems that the smart city is the key solution on how to face these challenges of fast growth urbanizations, transportations, environmental challenges and sustainability, and also citizen quality of life. And I also like to share another case study. And this case study is by Intel Smart Cities IoT Groups, were published in 2018 about smart city technology can save every resident about 125 hours a year. And this can be achieved through 4 factors, which are mobility, can save about 60 hours from smart traffic systems. Public safety can save 35 hours based on the predictions of the crime spots. Healthcare can save 9 hours through promoting better overall well-being. And another one is productivity can save 21 hours based on the simplified administration process through apps and digital services between citizens and city agencies. So, let me move to my presentation for today. My presentation from today, my topic will be divided into 5 subtopics, which is a JUPEM for overview, SmartKADASTER projects, Geomatics, data acquisitions, and a way forward. Let me start with general information about my department, JUPEM. JUPEM was one of the earliest agencies that providing survey and mapping activities since 1885. And this year, by the year of 2018, this year, we already established for about 133 years. We are responsible to provide survey, mapping, and geospatial informations for the countries and entrusted to do such activities so as to safeguard our country sovereignty. Our department activities are vital as they are to spur the social economic development. Our mission is to provide quality survey, mapping, and geospatial information through the best systems, competent workforce, and conducive work environment. And we are committed to provide services and activities of survey, mapping, and data disseminations with high quality standard based on the established standards and international standards for ensure our customer satisfaction. These are some of example of our products and services. We produce maps, digital maps, and hard copy maps with different scales. We do cadastral survey to identify cadastral lots boundary marks. We do utility survey to investigate and to identify cable underneath Earth surfaces. We do a lot of aerial imagery mapping using aircraft, UAV, and drone. And also, we do a lot of scientific research on mathematical model for establishing our national coordinate system and control points based on GNSS observations. So let me move to our project, SmartKADASTER. So, as we know, to fully maximize the potential of geospatial, a complete set of geospatial information need to be integrated into single informations for it to successfully work together. With that in mind, JUPEM has successfully spearheaded the development of Malaysia's very own 3D system model in line with FIG vision of Cadastre 2.0 with a project known as SmartKADASTER. This project was initiated in 2014 and 2015, and the main purpose of this project is to establish a multi-purpose cadastre-based spatial analysis platforms for effective planning, enhancing efficiencies, decision-making, and enabling communications and also management to support smart services in Kuala Lumpur and Putrajaya. And also, the aim of this project is to establish a multi-purpose cadastre-based spatial analysis platform to support smart services toward smart cities enablement in Malaysia with 2D and 3D interfaces based on user preference. So, SmartKADASTER, seeing is believing. All of you can access to this platform and web portal through this address, skip.jupem.gov.my map portal. You can see a 3D model of Kuala Lumpur and Putrajaya. And in our SmartKADASTER, we use a service-oriented architecture. This service-oriented architecture is a structure that allows services to communicate with each other across different platforms and languages. In SmartKADASTER service-oriented architecture, we have 91 data features and attributes with categories including built environments, demarcations, hydrography, transportation, and so on, as to name a few. And you can access this platform or this web portal through tablets, laptop, smartphones, and also desktops. In SmartKADASTER, we have 2D maps. Through 2D maps, we have 5 different base maps. You can view our maps in clear sky mode, night dreams with the night vision mode, aerial image based on our aerial imagery data acquisitions and the auto photos. And you can also view 2D maps with shaded relief with the result of the interpolation of digital terrain modeling and digital surface modeling, and also a hybrid view with the combination of all that I just mentioned earlier. And in 2D skip portal, we have 2D skip analysis. And this analysis, we have many functions such as to measure area, measure distance, calculate qiblat directions, search text function, and height calculations. And for measure area distance and measure area and area distance, for measure distance, actually there is different with other apps because in our 2D skip analysis, it will give also the bearings from point A to point B. And another one is 3D maps interface. In this 3D maps interface, we have 5 main functions, which are to navigate, sub-functions, view, measure, and analysis. And also in 3D skip analysis, we have a lot of analysis we can do with it. And I give 3 examples, such as to do contour map analysis, slope map analysis, and shadow analysis. And let me move to another topic of geomatics. And what is geomatics? Geomatics is one definition by the individual that expert in this field, Mr. Mario, and a professor. He said that it defined as a systemic, multidisciplinary, integrated approach to selecting the instruments and the appropriate techniques for collecting, storing, integrating, modeling, analyzing, retrieving at will, transforming, displaying, and distributing spatially georeferenced data from different sources with well-defined accuracy, characteristics, and continuity in a digital format. So, to make it simple, geomatics is an applied science and a professional discipline involve an integrated approach to the measurements, analysis, management, and display of geographic and other spatial data related to Earth. So the focus of geomatics is based on the products, services, and tools involved in collection, integrations, and management of data. And the areas of knowledge, geomatics have a lot of areas of knowledge. Some of it is example like in the slides, which are geodesy and geodetics, geovisualizations, photogrammetry, LiDAR, cadastral survey, spatial data analysis, GIS, hydrography, cartography, GNSS, and also computer visions, to name a few. So what it had to do with SmartKADASTER projects. So a lot of geomatics technologies, tools, and discipline being used in our SmartKADASTER projects. We use geomatics as our tools to get all the data acquisition and management of our geospatial data. First, I'd like to tell a little bit about aerial imagery. In this aerial imagery exercise in data acquisition, we use photogrammetry, one of the geometric disciplines, and we use a technique of oblique aerial imagery. Why we use oblique aerial imagery? Because if you want to build a 3D city model, you have to extract all the information about the structure or the buildings. The information that we need to build the 3D city model is such as the surrounding of the buildings, the roof, and also the facade of the buildings. So in our projects, we use an aircraft with camera Ultra Cam Osprey Prime, and the time taken is about 90 days with the result of 10,369 photos, include our 1,709 kilometers with 111 flight lines. And the best is that our aerial imagery and orthophotos result is 10 centimeter, the accuracy is about 10 centimeter or better. And this is some example of our 3D city model. This is high accurate 3D model of Tuanku Mizan Zainal Abidin Mosque. We are using aerial imagery photogrammetry with oblique aerial imagery. And if you see from these images, we can get all the information about the buildings, we can get the information about the roof, the facades, and also the surrounding of the buildings. And let me move to another one, LiDAR. LiDAR is short form of light detection and rangings. In this case, we need the point clouds because every point clouds of the futures have an information of X, Y, and Z of the futures. And in this case, we cover Kuala Lumpur and Putrajaya, and we use an aircraft, a laser scanner of Regals, camera Rolei AIC Pro P45, and the time taken is about 180 days, with 5,712 photos, includes of 1,332 kilometers with 95 flight lines. And our accuracy is about 10 centimeter and better. And this is the result of the combinations of aerial imagery and our LiDAR observations. We can produce contour maps, and we can interpolate for the result of digital terrain model and digital surface models, and is very important because from it we can do simulation of flood mapping and predicts any casualties. Example is which areas are affected, how many people affected, and others. Besides aerial imagery of using photogrammetry or oblique imagery and LiDAR, we also do mobile laser scanning. And by why we doing mobile laser scanning is because some of the information we can extract from the air, and we need to extract it, especially when the features is overshadowed by the bridge, or let's say that the roads or tunnel that can be accessed by aerial imagery. So in this case, we use laser scanner of Trimble, And we do control observation using a Trimble R8 with vehicle speed of 60 kilometers. The time taken is 120 days, and the accuracy is about 10 centimeter or better. So, another one is terrestrial laser scanning, and this one is more on research and development purposes. We need to establish our 3D model inside the buildings, and in this case, we use terrestrial laser scanning for scanning in our buildings, Wisma JUPEM and Bangunan UKO, and then from that we build a 3D model of the buildings. These are some of the examples. And for our way forward, for SmartKADASTER, what we expected that maybe in the future, if there is a budget and the policy is good, the area will be expanded, maybe to cover the whole of Klang Valley and also other cities in Malaysia such as Johor Bahru, Pulau Pinang, Kuantan, and any other cities. And also we need to think about how to reconstruct our 3D geomatics with non-spatial data, because nowadays there is a lot of research on how to integrate BIM and GIS. As GIS is 3D geometries, while BIM is non-spatial data, we need to think about it, because if we can successfully integrate this data, many people can use this data for data analysis. And for challenges, fourth industry revolution has already been discussed earlier. And also we need to think about how to create high definition maps. Why we need these high definition maps? Because in the future, some of the services in the smart cities is autonomous car. Autonomous car can move from point A to point B with normal maps or normal geospatial informations. They need very accurate informations. They need information with the high accuracy, because if they want to move the car, like to move from point A to point B, they try to avoid an accident and to have a safe journey from point A and to point B. And for that, we need to think about how we are going to create a high definition maps or high definition geospatial informations. And the other one is about 5G mobile technologies. If we see today, a lot of research been doing for these 5G mobile technologies, and I think within 3 or 5 years in time, the technologies will be matured, and by that time, the internet's connections and the telecommunication will be faster. If it's about 50% much faster than today. If let's say that we download a movie today, it takes 10 minutes. By the time 5G mobile technologies is already established, it will take a second to download a movie. So by that time, our user expectation is going to be very high expectations. They will need real-time data, up-to-date maps to do data analysis and data synthesis. So to conclude my presentation for today, the role of geomatics play an important an essential role for our department to gain the data acquisition, so we can provide a 3D city model, and from this 3D city model, it can support smart services toward smart cities enablement in Malaysia. Thank you very much. Assalamualaikum.